Hello, I would like to present you a very simple circuit with only two resistors in series powered by a battery of 9 volts. In our case is 9.5949 volts. One of the resistors is a potentiometer. The other one has a fixed value of 1 kilo ohm. This one has the potentiometer has from 0 to 10 kilo ohms. As such, we will be able to vary the resistance of the circuit and implicitly the intensity of the current through the circuit. Right now, as we speak, the circuit is open, and I will close it. What we know is that every battery has an internal resistance. So what does it mean? From the moment we start to use it, there will be a voltage drop from the nominal value, because the internal resistance will have a voltage drop on it. So it's the resistance multiplied by the intensity of the current. In the circuit, I have a voltmeter through using MyDAC, and an ammeter and a digital ammeter. The voltmeter measures the voltage drop on the terminals of the battery. The ammeter is just it's part of the circuit. I will close the circuit right now. And once I close the circuit, I see that the voltage on the terminal of the battery decreases from 9.5 to 9.41 volts, and this is because of the internal resistance of the battery. If I do something and reduce the current through the circuit, then the voltage drop will on the internal resistance of the battery will decrease, because the voltage drop is the intensity multiplied by the internal resistance. If the internal resistance is the same, then if the current decreases, I will have a lower voltage drop. Now I have a lower resistance and a high current of 9 milliamps. I increase the resistance, and if I increase the resistance, the current decreases because it tries to stay constant, but also the voltage of the battery increases also, because the drop of potential inside the battery is lower. So this is also maybe a very naive but still interesting way to calculate the internal resistance of a battery, to use a very simple circuit, and we don't even need to know the values, the resistance of the circuit. We know the intensity associated with voltage on the battery when the circuit is closed, and we know also the values of the voltage when the circuit is open. And again, if when the resistance is big, the current is low, and there is almost no voltage drop, is only 0.01 volts. But if I decrease the resistance, the intensity of the current will increase, and because the intensity of the current increases, then the voltage drop on the internal resistance of the battery becomes significant. And now the circuit is closed, and if I open it, suddenly the values are the differences in values are bigger. Again, I close the circuit right now. Okay, so this is the demonstration of the internal resistance of the battery, and this is also a way to increase the intensity of the current in a circuit. So to increase, when we have almost constant values for the voltage of the battery, we can increase the current by reducing the resistance of the circuit, no matter what circuit. Or we can increase the voltage of the power source of the circuit. In our case is a battery, and in some other cases are other sources of power. Thank you for your attention.